All right, hello everyone. Back on to the Algebra 2 projects this time. Okay, so we have Unit 4 right now with us, which is quadratic equations, and we are going to discuss about it probably very briefly if it goes well, and if it does not, not a problem. It will be a very big lecture thing. Okay, so the challenge name is Will It Go In? Challenge. And the steps are written over here. I'll read through it. Take a horizontal or vertical oriented video of yourself shooting a basket into a basketball hoop. Shooting a basketball actually into the basketball hoop. And I have a video linked over here that I recorded of myself doing that or demonstrating that, which is right here. Let's do it like this. See, the highest point is the vortex here, and then boom, it goes in. Now the thing is that I got this shot after 15 tries. I am not that good on volleyball, but that's all right. One of the Synlab students helped me with this, so thank you for that. I forgot the name, but thank you to that person. Thank you. Then the second step is edit the video in two halves. The part before the ball hits the vortex, and the part after the ball hits the vortex. So the first half is right over here, which I'll open it, and this is the first part. Does it still the vortex, which is the ball right here? If you see, so that's simply going to be the vortex. I'll replay this video. This is me right here in a very bad position of a basketball playing game. Let's go through it. 8 seconds. Start. So that's the first half part. Now let's go and check out the second half, which is the point after it hits the vortex. So it's a 25-second video. I don't know why, but it's good. This is the second half of the video. See how I did that. Here it's the vortex. This will be the considered as vortex, and then when I resume it, bam, there I go. At last I got the shot in the basket. I made 15 shots and two of them went in the basket, which is true. Very big relief after so many tries, right? Yeah. So this is the second part of that whole video after the whole 15 tries. So the third step says to take a screenshot of the end of the first half of the video and lay it over the graph paper. I have the image over here, but to make it more big, I'll bring that down here. So this is the image that I was talking about. It's on the Microsoft Whiteboard. Shout out to Microsoft Whiteboard for helping me out. And the background, I changed it with format background and it's graph now. So that's really cool thing about Microsoft Whiteboard. All right, so I created a graph right here with this and made a number line x and y axis. I forgot to write y axis right over here, which I'll write in sometime just now. Y axis, and I'm using my mouse to write on this whole whiteboard. I don't have a touchscreen laptop. Okay, so x and y axis are noted over here. The x axis is the width or the length from the basketball hoop till my position, which is denoted at 10 comma 0 if you talk in mathematical way. And this side, the y-axis is the height, is going to be the height of it. So That's pretty much the overview of it. Now, we talked about the vortex. So the vortex is right over here. When I give it, when I numbered on the graph, I wrote all the numbers. It came that it's fourth point on the x-axis and 13th point on the y-axis. So that is the vortex. So the vortex is equal to 4 comma 13 for x-axis and 13 y-axis. And this is me. I just made a funny photo of me. I'm very bad at drawing people. Very bad. I'm very bad in arts. Though I can draw some natural photos from the environment, such as lake or mountains, and it really looks realistic. Okay, back to topic. This is me right there, and my whole fourth step is to do the math and record a video with all the logic behind and tell whether the ball will go in or not. So as you saw the video, it's clear that you can see the ball did go inside the hoop. See, one thing's complete. Do the math. I have the math written over here. The math behind this is simple, really. It's very simple. We just needed 2 points. One is going to be the vortex, and one is the starting location, which is 10 comma 6. I'll tell you why it is 10 comma 6 and not 10 comma 5, because my height in this way it's 10 comma 5. Okay, so for the graph my height is at 10 comma 5, but technically my actual height is 10 5 by 7. And why I kept I throw the basketball from point at 10 comma 6. It's because while throwing I need to have my hands inclined a little bit upwards to make an almost perfect shot. So that's why I chose 10 comma 6. And it is true, while I was doing the whole shot on the video, I inclined the ball a little bit upwards so that I can get the shot inside the basketball hoop. With the above data, whoa, that's not how it spells above. Yeah. With the above data, I have my vortex point and another point that is 10 comma 6, which will make a parabola. So with that, I can make the quadratic equation for the parabola, which will become as y equal to negative 7 by 36 into bracket x minus 4 whole squared plus 13. And why, how I got this equation, I show you here. So I took the vortex form of the quadratic equation, and I just simply kept all of the values inside this equation. You see this whole equation right here, y equals to a into bracket x minus h whole squared plus k. That is simply it. Okay, this highlighter is very bad. Oh, it's going mad. Okay, so I plugged in all of the values that I had before. So the y value will be 6 because I had the pointer 10 comma 6, if you know. Then a value is something that we don't know, so we are going to find the a value. X is the x value from 10 comma 6, which is 10, minus h. H is the vortex x value, which is 4. If you know or not, the vortex is 4 comma 13, so the x value means the h value is 4 and the k value is 13. After we do all of this, 10 minus 4 is 6 and 6 squared is 36. So 36 into a equal to 36a plus 13, as it was right before. Then 6 will also stay on the left hand side. LHS, some people like to call it in LHS way. Then 6 minus 13, we bring 13 on the left hand side and then do the subtraction. 6 minus 13 is negative 7 equal to 36a, or you can write it as 36a equal to negative 7. And at the last point you get a value equal to negative 7 by 36. Hence the value of a is negative 7 by 36, and I keep it in the equation, and this is the defined equation for that shot. Now, if I wanted to show you how I did this on the graphing calculator, it's right here, Desmos. I plug down all of the values in the Desmos calculator, and this is what I get. See, the y-intercept is coming as 0.9.889, which is okay. It's almost near to 10, but that's fine. The vortex is 4 comma 13. The x-intercept is 12.177 comma 0. And you know what's the best part I liked about is it does intersect at 10 comma 6. See, I'll show you. Okay, please come on. Yep, see, it does intersect at 10 comma 6. So this is the best graph to have it done. Okay, so that's how it worked. Now, because I am performing this whole shot of I am on the right side and the basketball hoop is on the left side. If I had to flip it over and I had to keep myself on 0, which is this point, which is going to be the 0 point, this one here, then the vortex would have been changed from 4 comma 13 to 6 comma 13. It's very hard to explain all the math behind it, but that's going to be the right equation. And then there will be some minor changes in this whole thing. Technically it's not minor, it's major only, because you are changing all of the values with it. So, and at last this would change as x minus 6, and this value of a would also change. I don't know what it would be, but it will definitely change. And that's it for this time. If you want to see all my video on how I did it, I'll link it in the description. I guess I'll post it on the post this video also on YouTube. So I guess that's it. Thank you so much. See ya.